Hello, I'm Anna Mackay and this video is on the binomial distribution, and it's one of two videos. This first video will be about the theory and the second one will be an example. Hopefully this is revision for you, so I'll go through this as though it's a summary. So here we have Pascal's triangle and the different rows involved here. As you hopefully remember, you gain each number by adding the two above. So for example, this 6 would be calculated by adding the 3 and the 3 that are diagonally above with 1s on the end. These numbers end up being the coefficients of certain things that we're about to work out. So moving on, here's an example that we'll do to work through the theory. Consider a student sitting a multiple choice test. There are 4 choices for each question and they are going to guess each answer. So what are the chances of them getting that right? Well, that's 1 out of 4. There are 3 questions in total, and what's the probability of them getting 2 out of 3 correct? So we have to think of all the different combinations of getting 2 out of 3 correct. They might get 2 right and then 1 wrong, or they might get 1 wrong first and then 2 right, etc. So we would represent this by a tree diagram. So with 1 out of 4 being the chance of getting it correct, and 3 out of 4 the chance of getting it incorrect. And here's the first question, the second question and the third, and all the different combinations that could happen. So then here are the results at the end of each branch of this tree diagram. So here we have 3 correct, as you can see here, and there's only 1 chance of that happening. Likewise at the bottom end of the tree, getting 3 incorrect. There's only 1 way of getting to that, so that we would have none correct. But the one we're interested in is getting 2 correct. So having a look here, there's 1, 2, 3 ways of doing that. Correct, correct, incorrect. This combination here and down here. So on the next slide, we're going to look at this one in a bit more depth. So just remembering that there were 3 ways of getting 2 correct. Okay, so since the the questions are independent of each other, the questions in the multiple choice test, we can multiply the probabilities. So looking at the first one, what's the probability of getting correct, correct, and incorrect? So here's the probability of correct, multiplied by the probability of the next one correct, and then multiplied by the probability of getting it incorrect. Another way of writing this is we have 2 lots of 1 on 4, so that's 1 on 4 squared, multiplied by 3 on 4, gives us 3 on 64, or this number here. The second way of getting 2 correct is with the incorrect one in the middle. So as we can see here, that 3 on 4 is now the middle term. But when you multiply things together, you can shuffle around the order and it's still arithmetically accurate. And so having a look, that this is the same mathematically as the one above, because these questions are all independent of each other. And then the third way is the incorrect one comes first, but arithmetically that's the same combination, same order here, and here's our answer. So as you can see, there are 3 of those, 3 lots of 3 on 64. So we're going to fill this out here. Hope you're ready to write this down. So the probability of getting 2 correct, that's your probability statement, is 3 lots of, oh, hang on, that didn't like that. So 3 lots of this combination here. So I might just put that in a square bracket so we can see the difference. 1 on 4 squared times by 3 on 4. And that's the equivalent to 3 times 3 on 64, which is 9 on 64, or 0.141. Writing it as a fraction or a decimal is fine, either answer is correct. So we talked about the fact that there were going to be 3 lots of that probability. So just a side note here, this is the one that we've been discussing, the probability of 2 correct, and here's that 3 cropping up. Now, if we look at the combinations of other correct ones, 3 correct, 1 correct, or no correct answers, the coefficients are how many times they're going to happen. So the chances of getting, well, the number of times that you could get 1 correct answer is also 3 times. The number of times you could get 3 correct questions will only happen once. And these coefficients are the rows of Pascal's triangle, if you remember back from the first slide. So this is the formula, well, that we're about to write out, that is behind what your calculator does when it works out what we call the binomial PDF or the CDF functions. This is what's happening behind the scenes. So here's the official formula. In general, the probability of R or X successes, so our success was 2 correct questions, in N attempts. N was how many questions we had, which was 3. Sometimes these are called binomial trials, where the probability of each success is P, is given by, and so this is the official formula I'd like you to write down. We have, so capital P, the chances, the probability of, so we had X was equal to 2 in the question that we've just done, is, so it's called NCR. We describe it going from the top to the bottom, NCR. Hopefully that's revision for you. The probability to the power of R, so that's 2 questions right, it's the previous one, multiplied by the probability of the complement, so the chance of getting that wrong question, N take R. So if you can match this back up to what we did here, and we're just going to look at that in a little bit more detail here. So here's that formula that we've just written down. Let's just break it down to the question that we've just worked on. So our probability was a chance of getting it right, so that's 1 on 4, or 0.25. N is the number of successes, N is the number of trials, so, or attempts, so we had 3 questions, and we wanted 2 successes. So let's break all these numbers down and have a look here. So our probability statement, our NCR at the top is the number of trials, so there were 3 questions in total. We wanted 2 successes, so that 2 goes there. That 2 is also the same as this 2 up here, the number of successes. So the powers here must add up to the total number of trials. So they must add up to the top number at the beginning, so 3. And then in the brackets are the probabilities of success and failure. And together those probabilities add up to 1. So we're just going to put that into our calculators now. So have your calculators handy. So here's the slide that you've seen on the previous page. So we need to work this out. So we're going to do that in our run mode here. Whoops, we'll just delete all of that. Okay, so how do we access this NCR? So we go to correction. We have to do the 3 first. So we type in 3, and then we go to option and see what we've got here. Arrow across F6, we want probability. So pushing F3. Here comes the NCR. Push F3, there's that bold letter C come up, and now you have to put in the R, which is 2. And note here, you must use multiply. If you don't put a multiply in here, you'll get an error. And then we type in the rest as our fractions. So we've got 1 on 4 all squared. Feel free to speed this up. Oops, bracket first. You don't have to put the multiply here, but it's probably good practice. 3 on 4, oh goodness me, 3 on 4, close the bracket, enter, and there's that 9 on 64 that we worked out previously. Just going back to finish that off, just summarising what is a binomial distribution, the requirements. The trials have to be independent, so you can't rely on getting one answer right to then get the next one right. Then that's not binomial. There can only be 2 outcomes, a success or a failure, and each trial has to have the same probability of success. So that's the end of this video. If you like it, give it a thumbs up and subscribe to the channel. And the next video in this series will be an example of what we've just talked about. Thank you.